Okay,
So let's do a little recap on what you know about linear equations, or more specifically, straight lines. So we're looking at straight line graphs today. Straight line graphs, also known as the graphs of linear equations. Does anybody recall what is the equation of a straight line? What is the general or the standard equation of a straight line? Anybody? Yeah, fired. You're
I
going to say something.
the unexpected.
Y equals mx plus c, right? So every single straight line can take the form, or does actually take the form, y is equal to mx plus c. And in that equation, m refers to something and c refers to something. What does m refer to, guys, in the equation of a straight line? Y is equal to mx plus c. What is m? That's the coefficient of x. And what is c? The constant. What do those two things refer to?
M
Anybody?
is gradient.
M is the gradient, right? And what about C? We call it C as
The,
Evan.
The curve or something.
the
Uh,
y-intercept.
yeah, the y-intercept. Evan, that's clever. C curve, but it's a straight line. So M is the gradient, as Evan rightfully said, and C is the y-intercept. Who said it? Sorry, I don't have your names on the screen, so I don't know who's talking to me.
Liana.
Thank you, Aliana. M in the equation of a straight line represents the gradient of the line, and C is the y-intercept. The gradient tells us how steeply sloping a line is, and the y-intercept tells us where the graph cuts the y-axis, right? So there are some pieces of information that we can get from the gradient. So if you just see an equation of a line, you can tell immediately, once the equation is in this form though, y is equal to mx plus c, you can immediately tell whether how the graph, what's the general shape or direction of the graph, right? Because uh, lines, straight lines they can be increasing from left to right. So a line could be like this, a diagonal line increasing from left to right. It could be a diagonal line decreasing from left to right. It can be a horizontal line like this, or it can be a vertical line like this. And each of these lines have different types of gradients. So does anybody know what type of gradient what kind of gradient a line that is increasing from left to right, like this first one here, what kind of gradient would this be? What kind of gradient do you expect this line to have? So let me be more specific.
A
The
negative one.
gradient, that one actually would be positive, Alvin. And this one, decreasing from left to right, will be negative, right? So this one here, M, or the gradient for this one, a line that is increasing from left to right, this gradient is positive. So M in this case, M is greater than 0, right? In this one, Evan, when the line is decreasing from left to right, then the gradient is negative. So your gradient is negative when the line is decreasing from left to right. So M is less than 0. Evan, what about a horizontal line? Do you know what kind of gradient a horizontal line has? Sorry.
Um, Zero.
Yeah, correct. The gradient is 0. So it has no slope, right? So, and the gradient measures the slope of a line. So for a horizontal line, m is equal to 0. And then a vertical line. What about a vertical line? What about the gradient of a vertical line? Anybody knows?
I
What you said, honey?
I
It's undefined, right? So the gradient of a vertical line is undefined. So therefore, guys, from just looking at the equation of a line, we could tell whether we can already in your mind, you should be able to picture what is the direction of that line. What line? How is that line? Is it increasing from left to right? Is it decreasing from left to right? Is it just a horizontal line? Is it just a vertical line? Right? So we can tell that simply from watching the equation of a line. Okay, so I'm seeing a bunch of you just joined in, so let me just welcome everyone. Hi, guys. Good evening. Today, we are revising a little bit about straight line graphs and regions on a graph that represent like certain inequalities, right? So today, we're not doing full coordinate geometry. We've done that already, and we will do a full session where we're just going to do questions on it, like what we did last week. But today, in particular, because today is a little shorter, we're going to revise this, which is how do you sketch a line and how do you show a region that satisfies an inequality? So far we're brainstorming a little bit about what we know about straight line graphs. So one thing is that a straight line graph represents a linear equation, and all linear equations take the form y is equal to mx plus c, where m, the coefficient of x, is the gradient, and c is the y-intercept. That is where the graph cuts the y-axis. And then we were talking about the different types of gradients and how it would appear on a graph. So for instance, if you have a line that is increasing from left to right, you expect the gradient to be positive. So m is greater than 0. When the line is decreasing from left to right, your gradient is negative. So m is less than 0. If you have a horizontal line, there's no gradient there because there's no slope. Therefore, the gradient is 0, m is 0. And for a completely vertical line, the gradient is undefined. So for instance, an example of a line that has a positive gradient might be y is equal to 3x plus 2, right? So here, m, the coefficient of x is 3, and 3 is positive. So in this equation, m is 3. So the gradient of this line is 3. When the gradient is negative, well, this could be something like y is equal to negative x plus 1, right? Here, m is negative 1, which is less than 0, m is negative. So the gradient of this line, y is equal to negative x plus 1, would be m is equal to negative 1, right? If you have a horizontal line, you're not going to have any x value because m is equal to 0. And since the equation of a line is y is equal to mx plus c, if m is 0, you'll have 0x. So the equation of any horizontal line is always going to be y is equal to something. So for example, y is equal to 5. That would be a horizontal line passing through y is equal to 5, so passing through the point 0.5 on the y-axis. Because in this equation, y is equal to 5, m is 0, and c is 5. So it still is in the form y is equal to mx plus c, but there is no term in x, so you just have y being equal to c. And remember, just a couple minutes ago, we said that c is the y-intercept. So for a horizontal line, the equation of any horizontal line is simply y is equal to the value that it passes through the y-axis. So like, for example, it could be y is equal to 5. It could be y is equal to negative 3, right? These are both equations of horizontal lines. And then for when the gradient is undefined, well, this is simply going to be x is equal to any value, right? So like it could be x is equal to 10, for instance. It means it's going to be a vertical line passing through the x-axis at 10, right? So let's just take a look at what these this specifically these that I just did, I'm gonna open Desmos and let's look at how they would look on a straight line, on a graph, sorry. So give me one moment. I am now sharing the screen and you should be seeing Desmos, right? Everybody seeing it? The graph in the untitled graph on Desmos?
Yes, miss.
Okay, good. So the first one that we had just now, it was y is equal to 3x plus 2, right? And we expected it to be a line like this. As you can see, it's a line that is increasing from left to right because in this equation, m is positive, m is 3, right? So in this graph, right, in this graph, 3x plus 2, the equation, if I were to write it, it would be y is equal to 3x plus 2, where m is 3, m is equal to 3, and c is 2, the y-intercept. And as you can see on this graph, the graph passes through the point y is equal to 2. So this is the y-intercept here, 0, 2, right? And of course, it's increasing from left to right. So that's how this line would look. Another one that I had on the screen just now as the example, I had negative x plus 1, negative x plus 1. So notice negative x plus 1 is this blue line, right? So if it's negative x plus 1, that's really y is equal to negative x plus 1. So m in this one is negative 1, which means that the graph of that line is going to be decreasing from left to right, as you can see in this on the blue line, right? The blue line represents the equation y is equal to minus x plus 1. Of course, in this one, m is 1 and c is positive 1. So as you can see here, the graph cuts the y-axis at 0, 1 when y is 1. Right, so that's the relationship between the equation of a line and the line itself on the graph. So from just watching the equation of any line, once it is in the form y is equal to mx plus c, you can already tell how in your mind you could already sketch it because you would know where it's cutting the y-axis and which direction it is heading in, right? So if the equation is not in the form y is equal to mx plus c, you would have to write it over. So you'd have to rearrange it to put it in the form y is equal to mx plus c. So what I mean is like if I had an equation, let's say 3x plus 2y is equal to 5, right? This is still a linear equation because the highest power of x here is 1, right? So what I would do in order to write this equation in the form y is equal to mx plus c, I would simply make y the subject of the formula, or you could, in your head, you could just say solve for y. So what I'll do is I'll move all the terms from the left-hand side to the right-hand side so that I'm only left with y is equal to, well, whatever mx plus c is. So here I have 3x plus 2y is equal to 5. So I'll keep 2y on the left-hand side, keep 5 on the right-hand side, and I'm going to move 3x over to the right-hand side. Now, when you move a term from one side of the equation to the other side, you do the opposite of the operation. So I'll have to minus 3x here. So this will be 5 minus 3x. All right, so I'm getting closer to the form y is equal to mx plus c, but not quite because this is 2y and I need y. So what I'll do is I'll divide throughout by 2 to get 2y divided by 2 is y, 5 over 2 minus 3 over 2x. All right, so this is now in the form y is equal to mx plus c. If you want, you could use decimals, right? And you can put the x term in front. So you could have y is equal to negative 1.5x plus 2.5. 5 over 2 is 2.5. So now this equation, 3x plus 2y is equal to 5, is now in the form y is equal to mx plus c. It just took a little manipulation. So Here, the gradient of this line would be negative 1.5. So the gradient is negative 1.5 and the y-intercept is 2.5. C here is 2.5. So I'm expecting that my graph is going to be going down in that direction and it's going to cut the y-axis at when y is 2.5. So let's see what that looks like. So if I were to enter the value, so it's negative 1.5x plus 2.5. Guys, you see, it's a line that's decreasing from left to right, cutting the y-axis at 2.5. All right, so I could already tell that from my graph, from the equation, but only when the equation is in the form y is equal to mx plus c, right? So just now we also looked at when the gradient of the line is 0. So when you have a horizontal line, well, that would just be like when y is equal to a number. So if I were to say y is equal to 4, do you see? It's a horizontal line passing through y is equal to 4, right? If I wanted y is equal to negative 10, then it's going to be a horizontal line passing through y is equal to negative 10, right? So 0, 10. Also, y is equal to 0. That's going to be the x-axis, right? Because y is 0 on the x-axis. Now, the other one that we looked at is when x is equal to, well, when you have a vertical line, right? The equation of a vertical line is simply x is equal to a value. So like x is equal to 6, for instance, will be a vertical line passing through the point 60 on the x-axis. Or let's say x is equal to negative 3. It's a vertical line passing through the points 3, negative 3, 0. And finally, x is equal to 0 on the y-axis. So x is equal to 0 is just the y-axis. So guys, you have to be able to know, so far, you need to know what is the equation of a straight line. You need to be able to interpret what you are seeing in when the equation of a straight line is given in the form y is equal to mx plus c. You must be able to tell that m, the coefficient of x, is the gradient of the line, and c is the y-intercept. Furthermore, you have to make the connection that if that gradient is positive, then you're going to expect a diagonal line that's increasing from left to right. If it's negative, it's a diagonal line decreasing from left to right. If it's a horizontal line, the gradient is 0, so it'll just be y is equal to something. And if it's a vertical line, it's just going to be x is equal to something, right? So to sketch these two lines, like y is equal to something or x is equal to something, it's very easy because it's simply a vertical line, right? A vertical or horizontal line. Sketching another line like one of these, you really only need two things, to be honest. What I find is the easiest thing to do when I'm sketching a line, and if I want to be more accurate, because truly all you need to know is the gradient to tell you which direction to go, and the y-intercept to know where the graph is cutting the y-axis. But I like to do it a step further. I like to take it a step further and find the x-intercept as well. So this is the y-intercept is when x is 0, because it's where the graph cuts the y-axis. Similarly, the x-intercept is where the graph cuts the x-axis. So where the graph cuts the x-axis, y would be equal to 0. So let's just look. So this is my go-to for sketching a line, right? So let's say I have the equation. So I have the equation y is equal to 2x minus 5, right? So I have that equation, y is equal to 2x minus 5. This equation is in the form y is equal to mx plus c. What is m here, Tristan, and what is c in this one? I thought I saw Tristan in. Is Tristan here? Tristan, are you there?
Yeah,
Yes,
Miss
you are.
I.
What's m and what's c in this equation?
M is 2 and C is -5.
Yeah, so m is 2 and c is -5. So Tristan, am I expecting a line like this? This is 1, this is 2, this is 3, and this is 4. Which line am I expecting here? 1, 2, 3, or 4?
1
1. Why?
because the gradient positive.
That's right. So I'm expecting a line that's increasing from left to right because the gradient is positive. And where would the line cut the y-axis, Tristan?
At the point -5. Well,
Yeah,
0,
right?
-5. Yeah.
That's right. The point 0, -5. The line will cut the y-axis at 0, -5. Right? So I like to go one step further and I would want to know where the graph will cut the x-axis. So to find the x-intercept, guys, to find the x-intercept, you have to make y equal to 0, right? To find the x-intercept, make y equal 0 in the equation. So then you would have 0 is equal to 2x minus 5. So then 0 plus 5 is equal to 2x. And so 5 is equal to 2x, which means that x is equal to 5 divided by 2, or 2.5. Right? So the x-intercept here will be 2.5 and the y-intercept is -5. So the x-intercept for this graph is the point, it will cut the x-axis, will be 2.50, and where it will cut the y-axis is 0 and -5. So on a graph, right, this is my y-axis here and this is my x-axis. So it's cutting the y-axis at -5, right? So let's say that's here, right? So this is -5 here, right? And then the y-axis, the x-axis is cutting it at 2.5. So let's say that's here. Remember, this is not drawn to scale, right? It's just a sketch, so it doesn't have to be perfect. And it's gonna cut the x-axis here at 2.5, right? And here is 0, that's your origin. So my graph is going to pass through those two lines. Those 2 points, sorry, like this. And that would be the graph of the equation 2x minus 5. Right? This is the equation. This is the graph of the equation y is equal to 2x minus 5. So really, all we did here is we looked at the equation. We saw that m is 2 and c is -5, which are the gradient and the y-intercepts respectively. And then to just go one step further, I wanted to find what the x-intercept is, which is where the graph will cut the x-axis. And to find where the graph cuts the x-axis, you have to make y equal to 0. And once you did that, you would just be able to, you could just sketch the graph, right? So, and we also know that the graph is increasing from left to right because we identify the gradient as +2. And once you have a positive gradient, the graph is going to be increasing from left to right. So I'm going to try another one. Let's just do another one. All right. Shaniko, you're going to help me with this one. Shaniko, are you there? This one, y is equal to -3x plus 4. Right, Shaniqua, can you hear me? I'm seeing her here, but I'm not hearing her. All right. Um, let's see, Eliana.
Yes, ma'am.
Okay, let's look at this question here. Tell me, what is the gradient? What is M and what is C?
M is -3 and C is 4.
That's right. M is -3 and C is 4. So what kind of graph am I expecting? Like first one, second one, third one, or fourth one? Which direction would the graph take? 1, 2, 3, or 4?
The second one,
Yes. Why?
because the gradient negative.
That's right. The gradient is negative, so it's going to be decreasing from left to right. Thank you. And now, how do I find the x-intercept? Do you remember how to find the x-intercept?
You put 0 equals -3x plus 4.
Mm-hmm. That's right. And then I make x, this, I solve for x. So then this will be 0 take away 4, which was -4. -4 is equal to -3x. And so x is equal to -4 over -3, which is 1.33 recurrent because it's 1 and a third, right? So it's positive because negative divided by negative is a positive. So it's negative 4/3, which is the same as negative 1 and 1, sorry, positive 1 over 1 and 1/3 or 1.33. So on my graph, thank you, Eliana. So on my graph, I would have my axes, right? So I have my y-axis and my x-axis. And on my graph, I will have, so this is my y-axis here, and this is my x-axis. It's going to cut the y-axis at 4, right? So this is 0, 4, and cut the y-axis, the x-axis at 1.33. So the graph of this equation is going to pass through those 2 points, respectively on the y-axis. The y-intercept is 4 and the x-intercept is 1.33. So this is what your graph would look like. This is the graph of y is equal to -3x plus 4. So guys, that's just one step further is finding the x-intercept. Because once you have the equation, you could determine what the y-intercept is from simply reading it off. Once the equation is in the form y is equal to mx plus c. And to find the x-intercept, you simply make y equal to 0 and you solve for x. All right? So let's now talk about inequalities. All right, so guys, tell me, let me see. Aaron, I saw your message. It's okay. I know you're not feeling well. Um, and Zinga, tell me, what do you know about what are the different types of inequalities? Like what are they? Gonna look at inequalities now. Inequalities. Is Nzinga there? Nzinga, are you there?
Yes, miss.
Yeah, tell me a little bit about inequalities. What are the different ones? Any idea? Do you want me to give you a head
Miss,
start?
to be honest, I can't remember, you know.
All right, so well, tell me, what does this symbol mean?
It's greater than.
Right, that's greater than. What about this one?
Greater than or equal to.
Right, and then the next two are?
Less than or less than and equal to.
That's right. So less than and less than or equal to. What's the difference, Nzinga? Like if I have greater than, right? So like let's say I had x is greater than 5, right? Sorry, not largest, what's the smallest value that x, the smallest whole number that x could be equal to here if x is greater than 5?
1.
Greater than 5? Can x be 1 if x is greater than 5?
No, it would be more than 5.
So what's the smallest number it could take then? What's the smallest value it could take?
6.
Yep. So the smallest value, right? The smallest whole number, the smallest integer that x can take if it is um greater than 5. So the smallest integer that satisfies, I'm just using the language here, right? Because in CSEC, in your questions, you're going to see they're going to ask you what is the smallest or what is the largest integer that satisfies the inequality. So when I say satisfies the inequality, I mean it can be involved, x can be a part of this inequality. Because unlike an equation, if I told you x was equal to 5, well, x is equal to 5. X can't be equal to anything else. It's equal to 5. But if I tell you x is greater than 5, it means x can take any value that is greater than 5. It could be 6, 7, 8. It could be 100 because all of those numbers are greater than 5. And it could be just decimals too. It could be like 5.5 or 5.9, 6.7. However, when they ask you for integers, integers are whole number values. So the smallest integer that satisfies this inequality here is 6, right? Because 6 is the smallest number that is the smallest whole number that is bigger than 5. But what about, Nzinga, me and you again, what about if I said x is greater than or equal to 5? What would be the smallest value that x could take in this case?
5.
It can take 5. Why is that?
Because 5 is greater than or equal to 5.
That's right. That's right. So you see how you remember? So she said to remember. Right?
Yeah.
So yeah, so x in this one can actually be equal to 5 because of that equal to part, right? It's not just greater than, but it is equal to. So the smallest integer that satisfies this inequality would be 5, right? And then it could be anything greater than that. So it could be 5. X can be 5 in this case. X cannot be 5 here, but x can be 5 here. What about if I said x is less than -1? What's the smallest value that x could take? This is not fencing. It could be anybody answer me that question. If x is less than -1, what is the smallest value that x can be equal to? No, sorry, not the smallest number. I'm sorry. What's the greatest value that x can be equal to if it's less than -1? Anybody? If x is less than -1, what's the biggest value that x could be equal to? Jazara, is Jazara here? Jazara, are you there?
That's what
What value can x be equal to? +1? No, it can't be +1 because it's less than -1, right? What numbers are less than -1? Fire, tell me. I see you on mute.
A -2.
It can be -2, right? So hold on, just writing this. X can be 5 in this one. Here, the largest value that x can take is -2. Let's think about the number line, guys. If you think about the number line, right? So it's fine. It's easy to interpret when it's whole numbers. When it's negative numbers, sometimes that's where it could be tricky, right? So if you think about the number line, you have 0, and then you have your positive numbers to the right of 0. And then to the left of 0, you have your negative numbers. So you have -1, -2, -3, -4, -5, and so on. As you move to the left on the number line, numbers get smaller, right? Because they get more negative. And when you move to the right on the number line, numbers get bigger. So they get greater than. And when you move to the left, they get less than. All right? Because, well, as you can see, 2 is greater than 1, right? And 2 is greater than 0. So as you move to the right, numbers get bigger than or greater than. And when you move to the left, numbers get less than. So if x is less than -1, then x will be all of the numbers to the left of -1, right? So unlike with positive numbers, so like 2 is bigger than 1 on the positive side, but on the negative side, -2 is less than -1 because -2 is to the left of -1 on the number line. Or if you think about it in terms of like owing money, right? If you're owing somebody $5 and then you're owing somebody else $1, the person that you're owing less is the person who you owe $1, right? So in other words, your debt is bigger when it's more negative. So if you're owing $5, you're owing more than if you're owing $1. So as you get more negative, guys, the numbers become smaller, right? The value of the number is smaller. The value of -5 is smaller than -1. The value of -3 is smaller than +2. Because if you have $2 and you're owing $3, you're owing more than you have, right? So x is less than 1. The largest value that x can take in this case would be x can be any number that is -2 or less if we're looking at integers, right? Now, if x was, let me just move this around to the right. Right. If x was less than or equal to -1, then x can be -1 or any number less than that. So x can be -1 or any number less than it, right? But in this case, if x is just less than -1, x cannot be -1. Right? So in the same way, if x was greater than 5, x cannot be equal to 5. Or when x is greater than or equal to 5, x can be 5 because it's including 5. So similarly, if x is less than -1, then x cannot be -1. It could be -2 or any number smaller than that. However, if x is less than or equal to -1, it can be -1. So this leads us to the fact that these two, greater than or less than, they are called exclusive inequalities, right? So your exclusive inequalities are less than or, oops, but I'll spell inequalities for a second there. Inequalities, right? Exclusive inequalities are greater than or less than. And they're called exclusive because if the inequality x is greater than 10, then the number is excluded from the solution. So x is greater than 10 means that x is equal to any number that is bigger than 10 or more, right? And similarly, if let's say x is less than 5, well, x could be 4 or any number less than 4, provided that we're looking at integer values, right? So they're called exclusive inequalities because the value here is excluded from the solution set. And we can represent inequalities on the number line, right? So if you have a number line, let's do a number line here, right? So this is a number line. And let's say I want to show x is, so 0 is here. And 1, 2, 3, 4, 5. And then to the left of 0, I have -1, -2, -3, -4, -5. If I wanted to show the inequality x is less than 5, well, what I will do is I'll draw an unshaded circle above 5, and my arrow is going to point to the left because on the number line, all of the numbers to the left of 5 is actually less than 5. And I like to think of it in terms of to the left is negative, is less than, and to the right is greater than. So once it's an inequality that's less than, the arrow is always going to be facing the left, because when it's to the left, numbers get smaller as you move to the left. If I wanted to show x is greater than -2. Well, I'll put an unshaded circle above -2, and my arrow is going to face to the right, because all of the values to the right of -2 are greater than -2. Um, Zach, is Zach here today? I'm not sure if I saw Zach joining today. Zach, are you there?
No, Miss, you know, yeah.
Oh, okay. All right, Evan, let's do this one. What about if I wanted to show x is greater than 1? What would I do?
You will put the dot from the one without shading it, and
Yeah,
you'll put the arrow towards your right.
correct. So it's going to be a arrow pointing to the right, because to the right is greater than. This will be x is greater than 1. Beautiful. Let me see. Amisha, what about if I wanted to show x is less than 3? What would I do to show x is less than 3?
Miss, you would put um
Less than 3. So where would I draw the circle?
it would be between the 2 and the 3.
Well, it will be above the 3, right? So it will be above the 3, and less than would be to the left or to the right of 3.
To the left, miss.
Yes, to the left. So it will be like this, right? So this will be the inequality x is less than 3. Amisha, if I had put it between 2 and 3, then that would mean x is less than 2.5, because between 2 and
Oh,
3 is 2.5. So it has to go above the number itself, okay?
yeah, miss.
All right. What about Tristan? What about if I wanted to show x is greater than -4? Where would the circle go and where would the arrow go?
The circle would go over -4, and the arrow would go from, well, 4 going back.
What do you mean going back? It's left or right?
Oh, right.
Right. So this is x is greater than -4. Y'all, I'm putting it, it doesn't matter if you put it above or below. I'm putting it below because because of spacing, right? But all that matters is that that circle is in line with -4 on the number line, or it is in line with whichever number on the number line, and the arrow is pointing to the direction that is greater than or less than. So the arrow points to the right if it's greater than, because all of the values to the right are bigger than the values to the left. And likewise, all of the values that are less than are to the left, so the arrow points to the left, okay? So the next thing, so these are called exclusive inequalities because the value themselves are not included in the solution set. So for an inequality, you have a solution set, not just one solution, but a solution set. Because x, for example, x is greater than 10, the solution set there, x could be 11, 12, 13, 14, 15, any number greater than 10, right? And likewise, if x is less than -2, then x would be equal to -3, -4, -5, all of the values that are less than -2. And this is just talking about if they were integers, right? They don't have to be integers, but just for ease of explanation, we're using whole numbers. I say integers because whole numbers are only positive. Integers are all positive whole numbers as well as negative whole numbers. So that's why I use the word integer and not whole number, right? Okay, so guys, if these greater than or less than are called exclusive inequalities, what are greater than or equal to or less than or equal to? What do you think they are called? Greater than or equal to or less than or equal to? What do you think
Inclusive
we
inequalities.
That's right. It'll be inclusive inequality. Was that Enzinger who said that she didn't remember?
Yes, miss.
So you remember a bit, right? Or you're just using common sense. What is it?
I cannot remember now.
Nice. Right? So inclusive inequalities would be greater than or equal to or less than or equal to. And they are called inclusive inequalities because, for example, if you had x is greater than or equal to 2, then 2 will be included in the solution set. So x is greater than or equal to would mean 2, 3, 4, 5, and all the numbers that are greater than 2, right? And similarly, if x is if x is less than or equal to 12, then x will be equal to 12, 11, 10, and all the numbers less than, right? So this um, x is greater than 2 would refer to all the values. X could be equal to 2, 3, 4, 5, and all the numbers that are greater than 2. If x is less than 12, then x can be equal to 12, 11, 10, and all the numbers that are less than 12. But the main thing is that 2, the number is included in the solution set. And that's the difference between inclusive inequalities greater than or equal to or less than or equal to, and exclusive inequalities greater than or just less than. And similarly, we can do it on the number line as well. We can represent the inequality on the number line. So if you have, let's just do a few. So like if you have the number line here, and of course you have 0 in the middle, and to the left, 1, 2, 3, 4, 5. And then to the right, -1, -2, -3, -4, -5, right? If I want to show an inclusive inequality, you see how with the exclusive, we use the unshaded circle. So it's just like a circle like that, unshaded. For inclusive inequalities, we use a shaded circle. So x is greater than or equal to 2 would be a shaded circle above 2 with the arrow pointing to the right. This is the inequality x is greater than or equal to 2, right? If I wanted to show x is less than or equal to 4, it would be a shaded circle above 4 and the arrow would point to the left. So this is x is less than or equal to -4. And Amisha raised she made an interesting point, which was like, she said, putting it between two numbers, right? So like, for example, if I wanted to show x is greater than or equal to -1.5. Now, guys, -1.5 is going to be between -1 and -2, not between -1 and 0. Remember, on the left-hand side of 0, you're going up to the left. So negative 1.5 will actually be more than -1. So that's going to be, less than -1. So it's going to be between -1 and -2. So -1.5 will be here, right? Between -1 and -2. So if I'm looking at x is greater than or equal to -1.5, this is where I will put it. I'll put it above the halfway point of -2 and -1. All right. So please, this part I find it like interpreting the fractional parts on the negative side of the number line. Students always mix it up, right? Remember, you're counting from 0 and then you're moving to the left, right? So if you have between 0 and -1, you'll have -0.5. And then between -0.5 and -2, you'll have -1.5. Between -2 and -3, you'll have -2.5. So just like how it would be on the right-hand side, like if I wanted x is greater than 4.5, that's going to be between 4 and 5. So I put my circle, my shaded circle, above where 4.5 would be. That is between 4 and 5. And then I have my arrow facing the right. So this will be x is greater than or equal to 4.5. So therefore, if I wanted to show x is less than or equal to 4.5, negative 4.5. Firstly, negative 4.5 will be between negative 4 and negative 5, which would be here, right? And less than would be to the left. So this is x is less than or equal to negative 4.5. Right? Somebody fired. Where would negative 2.5 be? Between which two numbers will I find negative 2.5?
Between
Between negative 2 and
-3.
negative 3. Perfect. Right? Okay, guys. So that's how you would represent your inequalities on the number line. Just like we can represent inequalities on a number line by using the circles and the arrows, we can represent them on a graph as well, right? So on a graph, let's say we have, I'm going to draw x and y axis here, and these are not drawn to scale, right? So that means I'm just assuming, right? I wouldn't have anything crazy, like for example, I wouldn't put a negative number on the right-hand side on the x-axis, because I know that on the right-hand side of the y-axis, because on to the right of the y-axis, x is positive. So this is my y-axis and this is my x-axis. 0, the origin, is the center, the intersection of both of them, right? So like, let's say I wanted to show the region on the graph, x is greater than 2. Right? So if I want to show x is greater than 2, first of all, this is what type of inequality, guys? Is this an inclusive or exclusive inequality? X is greater than 2. Is it
Exclusive.
inclusive or? Sorry, Lavi, I spoke over you. What was it?
Exclusive.
Exclusive, right? It's exclusive because it's greater than 2. So that means that x can be all values that are greater than 2, and it does not include 2 because it's an exclusive inequality. So we would sketch the line x is equal to 2 on the graph, right? And as we know, x is equal to 2 is a vertical line passing through the point x is equal to 2, which is 0, which is 2, 0, right? However, because it's an exclusive, right? Because it's exclusive, we need to use, because it's exclusive, you need to use a broken line. So in the same way that with the number line, you would use an unshaded circle. On a graph, you're going to use a broken line. Because it's an exclusive, use a broken line. Right? So this is, let's say 2 is here, right? Greater than 2 is going to be all the regions to the right of 2. Because here would be 1, here would be 3, 4, and so on, right? -1, etc. So you would have a broken line passing through x is equal to 2. So this line is x is equal to 2. That's the line x is equal to 2, right? And then the region that satisfies this inequality would be everything to the right of 2. So everything to the right of 2 is greater than 2. So this region on the graph represents the inequality x is greater than 2. Right? Is that okay, guys? Guys, everybody understands?
Yes, miss.
Perfect. Right? So to sketch to show the region that satisfies x is greater than 2, you first have to sketch the line x is equal to 2. Since it's exclusive, since it's just greater than, you will use a broken line, right? So let's say we had to show the region on the graph, show the region where, so show the region where, show the region that satisfies the inequality y is less than -3. So first of all, let me just sketch the Cartesian plane. You have your y-axis, which is your vertical axis. And then you have, sorry, this is so bent. Yes, this is better. Right, so your y-axis, and then you have your x-axis. Right? This is y, this is x. The center is the origin. Y is -3. Well, y is negative below the x-axis. So here you'll have -1, -2, -3, -4, -5, -6, and so on, right? So if I want to show the region where y is less than -3, I first need to sketch the line y is equal to 3. The line y is equal to 3 is going to be a horizontal line passing through the point 0, 3. So this line that I just sketched here, this is the line y is equal to -3. And the region that satisfies the inequality y is less than -3 is below -3, because all of these numbers are less than -3. So this is the region here this is y is less than -3. Right, guys? So that's how you would show the region. Now, just like I can show the region. Oh, wait. So before I move on to like another one, let's look at the inclusive inequalities now. So this one is x is greater than 2. This one was y is less than -3. The exclusive inequalities, you use broken lines, right? For the inclusive inequalities, what type of lines do you think we'll use for the inclusive inequalities? What do you think, guys? What kind of line? Anybody? Y'all did this before or no? So if it's a broken line, what's it like another type of line? Okay, maybe that's just like not a good question. I'll give you all a blind. Maybe that was a poor question. So this is your y-axis here, this is your x-axis. Let's say I wanted to show x is less than or equal to -3. This is my y-axis, this is my x-axis. My origin is here, 0, 0. To the right, I have my positive numbers. To the left, I have my negatives. So -1, -2, -3, -4, and so on. Above the x-axis, y is positive. And below the x-axis, y is negative. Right? So if I want to show where x is less than or equal to -3, it's an inclusive inequality. The first step is to sketch the line x is equal to -3, which is going to be a vertical line passing through x is equal to -3. It's a solid line, guys, right? So it's not a broken line. For inclusive inequalities, that is greater than or equal to or less than or equal to, you have to use a solid line. So this is my line here. This is my line. X is equal to -3. And if I want to show the region where x is less than or equal to -3, that region is to the left of -3. So this is the region that I'm shading. This is the region x is less than or equal to -3. All right, let's say I wanted to show the region y is greater than or equal to 1. If I want to show the region y is greater than or equal to 1, let me sketch my Cartesian plane quickly. Y'all, I would like you to write down all of these notes after. I know I'm switching slides quickly, but afterwards, please write down these notes in your notebooks. It's good notes to have. Right, so this is the y-axis, this is your x-axis, your origin is here. To the right of the y-axis, x is positive. To the left of the y-axis, x is negative. Above the x-axis, y is positive. and below the x-axis, y is negative. All right, so the first thing when you're sketching, when you're showing a region that satisfies the inequality on a graph, you need to sketch the line that corresponds to the inequality first. So y is greater than or equal to 1. That means I have to sketch a line y is equal to 1. Because this is an inclusive inequality, the line will be a solid line. So it's not a broken line, it's a solid line. Right? So this line that I just sketched here is the line y is equal to 1. It's a horizontal line passing through y is equal to 1. And then it's greater than or equal to 1. So the area that I would have to shade is all of the values above 1. So that would be here. This region here is y is greater than or equal to 1. So let's recap quickly before we move on. If you are sketching the inequality, if you're representing it on a number line, for your exclusive ones, which are greater than or equal to, you use an unshaded circle above the value. If it's greater than, the arrow will point to the right, and if it's less than, the arrow will point to the left. When you're looking at inclusive inequalities, that is greater than or equal to or less than or equal to, you use shaded circles above the value, and for less than or equal to, it goes to the left, and for greater than or equal to, it goes to the right. So it's the exact same as the exclusive inequalities, except for exclusive, you leave a unshaded circle, and for inclusive, you shade the circle. Right? Now, when you are showing the region that satisfies an inequality on a graph for exclusive inequalities, that is greater than or less than, you have to use broken lines. The steps to show a region on a graph is first to draw the line that is corresponding to that value. So to show x is greater than 2, you first need to sketch the line x is equal to 2. You're going to use a broken line because it is a exclusive inequality. And once you sketch the line, you then choose the part. If it's greater than, it's going to be to the right, provided that it's x, right? Because it's to the right of the number 2 on the x-axis, all the values are greater than. So that's why you would sketch that region. If you had an inequality, let's say y is less than -3, you first need to sketch the line y is equal to -3, which will be a broken line passing through y is equal to -3 on the y-axis. And since it's less than, you would have to shade, the region below y is equal to -3, as all the values beneath that -3 are smaller than it. When you're showing the regions for inclusive inequalities, you use solid lines. So you sketch the line, but instead of it being broken, it has to be solid. So if you want to show x is less than or equal to -3, you first need to sketch the line x is equal to -3, and it must be a solid line. Similarly, y is greater than or equal to 1. It had to be a solid line, a solid horizontal line passing through y is equal to 1, and the values above 1 all of those values are in the region that is greater than or equal to -1. Now, you can have like an inequality that looks like this. Like, let's say you had 3x plus 5 is equal to y, right? And if I want to sketch this inequality, oh, sorry, not is equal to 5. Sorry, I wanted to say, hold on. I wanted to say 3x plus y is less than 5, right? So I want to show this on a graph. I want to show the region that represents this inequality 3x plus y is less than 5. So first thing, just like with all the others that we looked at, you first needed to draw the line, right? So for this, 3x plus y is less than 5. I first need to draw the line that corresponds to this equation. However, as you know, in order to sketch the line, I need to have, well, you don't need to, you could just use some values and substitute it and then just sketch the graph. But I think the more accurate way to do it is to write this line in the form y is equal to mx plus c. So if I'm writing this line, remember we're going to be looking at 3x plus y is equal to 5, right? We need to draw the line first, and then we would be able to show the region. So if I'm looking at the line 3x plus y is equal to 5, I'm going to write this in the form y is equal to mx plus c, right? So y is equal to negative 3x plus 5, because I want to make y the subject. And here, the y-intercept is 5, so I know that the graph is going to cut the y-axis at 5, and I need to find what the x-intercept is. I also know that the gradient is negative 3, so I'm expecting this line to be a diagonal one, decreasing from left to right? So I'm expecting that. So to find the x-intercept, I make x equal 0. I make y equal 0. So the x-intercept of this line, x-intercept would be 0 is equal to negative 3x plus 5. So then I'm going to put 3x on this side. 3x is equal to 5. So then x is equal to 5 over 3. Right? Which is 3.67 to 2 decimal places, right? So the x-intercept here will be 5 over 3, or that is 1 point, not 2, I don't know why I said 2, 1.67. So on a graph, remember the first step when you're showing a inequality is that you need to draw the line, right? So on the graph, we'll have, this is my y-axis and this is my x-axis. So x, and it's just a sketch, it doesn't have to be drawn to scale. The y-intercept is 5, so let's put 5 up here. And then the x-intercept is 1.67. So let's say that's over here, right? 1.67. So the line that represents this equation, 3x plus y is equal to 5, is going to look something like this. All right, guys? This is the line. This is the line. 3x plus y is equal to 5. 3x plus y is equal to 5, right? So now I have my line, but I made a mistake because remember, this is exclusive inequality, right? This is 3x plus y is less than 5. So that line shouldn't be a solid line. It should actually be a broken line. I was just trying to draw it properly and I forgot that. So let's just put it like here. Sorry, I can't use a proper line, but pretend that's a solid line, right? I don't have the option to make a broken line. So yeah, so that's a broken line. That's the line 3x plus y is equal to 5. Now we need to find the region, whether it's going to be to the left of the line or to the right of the line, that satisfies the inequality. So here's what you do. You take 2 points on either side of the line and substitute them into the equation to see if it makes sense, right? Well, substitute it into the inequality. So the points that I like to take easy points, right? So to the left here, I have the origin. And the coordinates of the origin is 0, 0. And then I could choose a point anywhere here. So like this point, for instance, let's say this point is 4, 3. So this point is 4, 3. So what you do is you take two test points and you substitute them into the inequality to see if it satisfies the inequality. So let's use 4, 3 first and see. So I'm going to substitute the point 4, 3 into the inequality. That is 3x plus y is less than 5. So x here is 4 and y is 3. So 3 times 4 plus 3, is that less than 5? Well, 3 times 4 is 12, and 12 plus 3 is 15, and this is not less than 5. So that means this point is not in the region that satisfies the inequality. It's not in the region, right? So that's this point does not work. So obviously it has to be the other point, the other side. However, if you just want to be very, very, very clear, very certain, you can then substitute a point to the left of it. So you see this point here, that's the origin, that's 0, 0. So let's see if the origin is in the region that would satisfy, the inequality 3x plus y is less than 5. So x is 0, y is 0. So it'll just be 3 times 0 plus 0 is less than 5. And this does work because 3 times 0 is 0. So 0 plus 0 is 0. And 0 is, in fact, less than 5. So that is the point that is in the region. So this region here satisfies the inequality 3x plus y is less than 5. Right? So unlike when it's just like x is equal less than or equal to something or y is greater than something, it's quite easy to tell. But when you have a linear equation where you have like x and a y, then you have to take a point on either side of the line and test it into the inequality to see if it makes sense. So for this one, the 2 points, I took a point to the right of it. I took the point 4, 3, and I substituted it into the inequality to see if the left-hand side is less than the right-hand side. And it did not work out that way because the left-hand side ended up being 15, and 15 is not less than 5. So that means this point is not in the region that satisfies the inequality. However, when I chose the point to the left of it, and I chose the origin because it's just an easy substitution, I got 0 is less than 5. And that is true. And so that is the region that satisfies the inequality, right? Let's do another one. This will be the last one that we get to do today. So let's say I had the equation 2x plus y is equal negative 2x plus y. Let me write this over. Y minus 2x is equal to 4, right? Not equal, greater than or equal to 4. So y minus 2x is greater than or equal to 4. Your first step is to write this as a linear equation, right? So you just, instead of the greater than or equal to, you're going to change it to equal. So then you're going to write y minus 2x is equal to 4, right? And if y minus 2x is equal to 4, if I put this in the form y is equal to mx plus c, it'll be y is equal to 4 plus 2x, where the gradient is positive 2 and the y-intercept is 4. So the x-intercept here, well, to find the x-intercept, I would have to make y equal 0. So the x-intercept will be 0 is equal to 4 plus 2x. So then negative 4 is equal to 2x. And so x is negative 4 divided by 2, which means x is negative 2. So now I know my y-intercept is 4 and my x-intercept is negative 2. I can go ahead and sketch my line. So that's the first step, right? The first step, guys, is to sketch your line. You make the inequality an equation and you sketch that line. So I made y minus 2x is greater than or equal to 4. I changed it to y minus 2x is equal to 4. And now I'm going to sketch my line. Right. So That's the first step in the inequality. So it's negative. This here is my y-axis, here is my y-axis, and here is my x-axis. And the gradient here is positive 2, so I expect it to be a line increasing from left to right. And the x-intercept is negative 2, so it's going to cut the x-axis at negative 2 and the y-axis at 4, positive 4. So it's going to look something like this. Remember, this is not drawn to scale, right? So it doesn't have to be. And the reason it's a solid line is because it's greater than or equal to. And once it's greater than or equal to, it will be a solid line. A solid line is used for inclusive inequalities. So this point here is 4, and this point here is negative 2. All right, so now we need to shade the region that satisfies this inequality. Y minus 2x is greater than or equal to 4. So I have to choose 2 points. I'm going to choose this point here. This is the origin. That's my first test point. And then the other test point I can choose will be, let's say, negative 3, 3. Right? So negative 3, 3. So I'm going to choose a test point here, and that's negative 3, 3. All right, so let's test negative 3, 3 to test it. So we test it by substituting negative 3 and 3 into the inequality. So that would be y is 3. So 3, take away 2 times negative 3. It's supposed to be greater than or equal to 4. Let's see if it works out. Well, 3, negative 2 times negative 3 is plus 6. So 3 plus 6 is 9. And 9 is, in fact, greater than or equal to negative 4. So that's the point. That's the one that works. But let's check the other one just in case. So we're going to test 0, 0. To test 0, 0, we substitute 0, 0 into the inequality. So that would be, so testing 0, 0. So this one was testing 3, well, negative 3, 3. And this one is testing 0, 0. So I'm substituting it into the inequality. So 0 minus 2 by 0 is greater than or equal to 4. No, it's not, because 0 take away 0 is 0, and 0 is not greater than or equal to 4. So that means this point is not in the region that satisfies the inequality. The point that is in the region that satisfies the inequality is negative 3, 3. So I will shade the region that that point is included in. That's this region. And this region is the part of the graph that satisfies the inequality y minus 2x is greater than or equal to 4. Right, guys? So we're going to stop here for today.